In this video, we're going to have a look at how we can find all the possible outcomes, or the sample space, of multi-stage events. So when we're talking about multi-stage events, then we're talking about more than one event occurring at the same time or simultaneously, or even back to back. So it's quite often useful to know all the possible outcomes so that we can work out probabilities from there. So we'll look at probabilities another time, but let's just have a look at how we can come up with the sample space. So here's some examples of some multi-stage events. When two coins are tossed, a pair of dice rolled, the gender of 3 babies born. So we'll look at these events and how to find the sample space of all of these. So let's look at an array or a table, which is one method of finding out the sample space. It's quite useful for when there's 2 events, but when there becomes 3 or more events, then it becomes a little bit hard to do so using a table. So let's look at for 2 events when 2 coins are tossed. So we're going to set up a table, and our first coin we're going to say is in the blue here, heads or tails, and then our second coin down the side here, heads or tails. And I'm just using different colours there to highlight the different possibilities. So the first coin could land on heads, and then the second coin can also land on heads, giving us a double heads. We could have also had the first coin landing on heads and then the second coin landing on tails. So at this point in time we have double heads or heads tails occurring. But the first coin could have also landed on tails first, and then the second coin could have landed on heads. Now when you toss 2 coins at the same time, these look the same when in fact they're different. And then we can also have the first coin landing on tails and the second coin landing on tails as well. So what we've come up with all our possibilities, so you can see that is our sample space. All of that in there is what we call our sample space. And we can see that there are 4 possibilities in our sample space, which, as I said before, is quite useful when we're trying to work out the probability of an event. For instance, if I wanted the probability of both heads, then that would be 1 in 4. But as I said, we'll talk about that at a later time. What we're now going to have a look at is a pair of dice. So again, we'll set up a table, and our first die coming across the top, and our second die coming down the side, and we'll have a look at our possibilities. So the first die could land on a 1, and the second die also a 1, and the first die on a 1 and the second die on a 2, the first die on a 1, the second die on a 3, and I think you'll get the process there. So that's all the possibilities if the first die lands on a 1. Then we could also have the first die landing on a 2 and the second one on a 1, and also a double 2, first die on a 2, second die on a 2 also. And then there's all our possibilities for when the first die lands on a 2. And we can do the same thing for the first die landing on a 3, 4, 5, 6, etc. And so we've done all the possibilities. Now again, when we usually do board games, we do the dice simultaneously at the same time, and so we can't usually tell the difference between a 3-4 and a 4-3. But there are our 36 possibilities there for working out our sample space. Okay, so that's just to highlight our sample space there. And so for 2 coins, there's our sample space. For a pair of dice, there's also our sample space. So that's using a table or an array. But there's also other methods that we can use. So for instance, a tree diagram. So let's again look at the 2 coins that are tossed. Let's look at our first coin. Now we know for a coin that there's 2 possibilities. So let's have 2 branches here of our tree for those 2 possibilities, and heads for our first possible outcome and tails for our second one. Now instead of me writing the whole word heads and tails, I'm just going to abbreviate it, so H and T for heads and tails. Now, what we're going to do is have a look at our second coin. Now our first coin could have landed on heads, and then our second coin can branch off that and land on heads or tails, or our first coin could have landed on tails, and again we branch off for the two outcomes for our second coin. So we could have had first coin heads, second coin heads, first coin heads, second coin tails, first coin tails, second coin heads, and first coin tails, second coin tails. So we read along our branches to determine our sample space. So let's list our sample space. Remember, it's the list of all possible outcomes. So along the branches, heads, 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 tails, tails, heads, and tails, tails. So what we've then come up with is exactly the same sample space there as what we did when we compare it to the table. Okay, so same sample space. So does it matter which method you use? No, as long as you can understand how you get all of them. Some people, instead of using an array or a tree diagram, just like to write a systematic list. So start off with heads, and then heads, heads, then tails, so there's no more possibilities. Then start off with tails and heads, tails and tails. But when you have quite a few in there, then some people, when they do a list, tend to miss some. So it's better to either do a table or a tree diagram. Okay, so let's look at another example. So let's have a look at a pair of dice using a tree diagram. Well, we know a single die has 6 possible outcomes, so then we can have our 6 branches for all of those 6 outcomes. And I don't know whether you can see it already, but you're going to find something that's not going to be very useful for us, because our second die is also going to have 6 outcomes, and we've got to have those coming from each of these branches, and you've guessed it, it's then going to become very messy. So in some situations, it's going to be better to do a table than it is to do a tree diagram. So for a pair of dice, yes, you could use it, but you'd need to give yourself plenty of space to be able to set up your tree diagram so that you don't have this type of thing happening, and that you can read off each of your outcomes. So let's have a look at another example. The gender of 3 babies when born. So what we do know is that our first baby, and I'm going to use boy and girl. I'm not going to be politically correct and have gender neutral, etc., but I'm going to have boy and girl for the sex of the first baby, because we've got 2 possibilities. And then our second baby, just like we did with our coin, we can have a boy or girl branching off that, or a boy and girl branching off that. So for 2 babies, we can have a boy, 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 girl, girl, boy, and girl, girl. But we don't want 2 babies, we want 3. So we're going to now have 2 possibilities off each of those. Again, I might have squashed it a little bit, but I think I can get my diagram in okay. So for our third baby, again, 2 possibilities coming off each of those. So there's our tree diagram for 3 babies, or 3 children. But what we haven't come up with yet is our sample space, which is the list of all the possibilities. So read along our branches. Our first baby could be a boy, second boy, and third a boy. Or we could have our first a boy, second boy, and then the third a girl. So boy, 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 girl. Then we can do boy, girl, boy, boy, girl, girl. And we keep following along our branches, girl, boy, boy, and finish up our sample space. So as you can see, that for 3 children, there are 8 different possibilities there. Okay? So for instance, if I wanted to know the probability that all 3 children were girls, then I've got a 1 in the 8 possibilities. If I wanted the probability of 1 boy, well, there's 1 boy, there's another 1 boy, and there's another 1 boy, so there is 3 out of the 8 possibilities. Okay, so that's a tree diagram, and certainly does make coming up with a sample space easy for when we've got more than two events happening simultaneously, or one after the other. So what you need to now do to be able to find your sample space easily is to practice. And just like in football or basketball or any other sport, to get better you also need to practice again, and then practice again. And the more that you practice, the easier that it will all become. So I hope you found this video useful, and if you need to, go back and watch it again or see some of my other videos to get some more help. Thanks for watching.